Good evening, students. Sir, good evening. Sir, I am audible. Hello.
Good evening, sir.
Yeah, yes. Thank you. Thank you. So, good evening, students. I am Papa Rao. Today, I am going to teach you compiler design subject for GATE. So, I think you completed compiler design subject in academics. Am I right? Can you please anyone respond? Are you finished your academic subject as a compiler design?
No, sir, we have it in this semester.
In this semester. Okay. Thank you. Right. So, coming to the any GATE subject, first we have to know the weightage of the subject in GATE. So, how many number of marks or how many percentage of marks we are getting with that subject, we have to know. Coming to the compiler design subject, so up to 2018, the weightage is 4 to 5 marks. But from 2019 to per this year, 2022, the weightage of marks increased. Now it is 6 to 8 marks. So the weightage of the compiler design subject in GATE examination is minimum 6 marks and maximum 8 marks. So this is not a compulsory, but so maximum in this category will get the questions. So I mean what I'm telling is the weightage of the compiler design subject is increased in these years. So, and one more thing is compiler design subject, we can easily answer the questions. So compared to other subjects, coming to the compiler design subject, we can score 100% of marks. I mean, we can answer 6 marks, or suppose 2 1-mark questions are asked and 2 2-mark questions are asked. For example, we can answer for 4 questions like. So that is I'm telling. So coming to the compiler design, so there is a topic weightage also. In compiler design, we are getting 6 to 8 marks. So that is the good weightage in GATE, because suppose if you get 30 plus marks, we can qualify in GATE. Anyone can qualify in GATE. Almost every year the qualifying mark is nearer to 30 or 25 to 30 only. So in some cases only it is increasing. So that's why 30 marks is nearer to qualifying marks. That's why 8 marks from compiler design is a good score. So we can, if you can concentration on this subject, you will get the good marks. So coming to the topic wise coverage. So in compiler design, we are having 6 pages. One is lexical analysis, and second one is syntax analysis, semantic analysis, intermediate, code generation, code optimization, and code generation. So these are the phases of the compiler. Coming to the GATE examination, so we can score 10% of the weightage. So suppose if it is 8 marks, you can get 1 mark. from lexical analysis part. Coming to the syntax analysis, this is the 50% weightage. So you can score more from syntax analysis. So, and coming to the semantic analysis, or SDT, syntax directed translation. So from this part, we can expect 30%. And coming to the remaining all, that is 10% weightage. So most of the questions covered from syntax analysis and semantic analysis. So we need to concentrate more on syntax analysis and semantic analysis. So this is the topic wise weightage. So coming to the compiler design, we can we may expect 6 to 8 marks. That means 1 mark questions and 2 marks questions. This is not a mandatory, sir. This is expectation only from the previous year's analysis of the previous year's question paper analysis. So coming to the topic wise analysis also, the more weightage is given to syntax analysis and semantic analysis. Coming to the lexical analysis, we can get 1 mark question. So based on most of the cases, it is a theoretical question only. I will explain you each topic very fluently, clearly. So after that, we'll do some questions. The pattern of class is, first I will explain the topic, then after that we'll do some questions. After that we'll explain you. I will explain you the previous questions, sir. So this is the pattern of our class. So this is the weightage of the compiler design. So next point is, sir, what is the prerequisite to learn compiler design? Sir, what is the prerequisite to learn compiler design? Is there any subject knowledge or other subject knowledge required to learn compiler design? You need some prerequisites. Those are, one is finite automata, second one is regular expressions, and third one is push down automata, and fourth one is context free grammars. Sir, these are not mandatory, but if you are having knowledge on these areas, it is good for you. Even though you don't have knowledge on this, or if you forget these topics, I will explain you clearly every point. Finite automata I will explain, regular expressions I will explain, push down automata I will explain, and context free grammar also I will explain where that is required. So, but if you are having knowledge on these areas, if it is good for you to understand the compiler design subject easily. So this is the prerequisites for the learning the compiler design. So, and third one is the introduction for compiler design. So what is compiler design? Compiler design. So there is a two words. One is compiler, another one is design. So compiler is a program, or else we can call as collection of programs. Collection of programs. We can also call it as a software. What I'm calling compiler is a software or a program or a collection of program. We know that program. Program is a collection of instructions to do a specific task. To do a particular task, we can write the program by using some instructions. Like that only, compiler is also a program or collection of programs or software. That means by putting some programs at one place, we formed a compiler. So compiler is the program. Sir, we know the definition of the compiler. Compiler is not a program, sir. It's a translator, sir. Yes, sir. It's a translator only, but it is the program. So what it translates? What is a translator? So compiler is the definition, another definition for the compiler, and your textbook definition is compiler is the translator. Compiler is the translator. What it translate? Sorry, translator. What it translates? So from the given source language or source program to target language or target program. Sir, what is the source program or source language? Source language is the high level language, and target program or target language is the low level language. Sir, what is the difference between low level language and high level language? High level language is the language which is understandable to the users, and coming to the low level language, the language which is understandable to the machine. So we can give the definition for the compiler is the software which is used to translate the source program into target program. So target program may be, sometimes it is a low level language, and sometimes it may be assembly language, or sometimes it may be a byte code, any target language or any target program. So input is high level language, or source program is high level language, that may be C or C++ or Java. So this is the high level language. So this high level language is converted or translated by using compiler. As suppose if it is a C language, we can convert it as assembly language, or C++, it is also converted as assembly language. Coming to the Java, it is converted as byte code. So finally, the compiler is the translator or a software which translates the language which is written in high level language into the target or machine level language. That may be a machine level language, or that may be a target language or the target program. Why we are calling as a target program, sir, or target language, sir? Because sometimes the translated language is assembly language, or sometimes it may be machine code or machine understandable language, that is nothing but low level language, that means zeros and ones also. And sometimes it is a byte code based on the program and based on the compiler. Here we use a C compiler, here we use a C++ compiler, and here we use Java compiler. So the Java compiler converts the high level language into target program as a byte code, and C language is converting the low level high level language into assembly level language. So that's why we are calling this one as a target program or target language. Hope it is understandable, sir. So if anyone are having doubt in a definition of the compiler, you can ask. I will again explain you, because without knowing the terminology in compiler design, so it is difficult to answer the questions. We need a clear understanding of the definition terminology, sir. In compiler, we need to know the clear terminology, so it will be very helpful to you to answer the questions. So once again, I am repeating, compiler is the software which is used to translate the program or code which is written in high level language into the target program or target language or low level language or machine understandable language. For example, C, C++, Java. So C is converted as a assembly language, and C++ is also converting as a assembly language, and Java is converting as byte code, sir. So this is the definition of the compiler. This is the definition of the compiler. But we need to learn compiler design. We need to learn compiler design. Sir, what is a compiler design? Compiler design means in the process of converting the high level language into target program or target language, we need to design techniques or tools how to convert high level language into low level language. For this task, we need to write a program, or we need to write a tools, or we need to design a tools. That is nothing but that is nothing but compiler design. That is nothing but compiler design. So compiler is having one more compiler is doing one more task, sir. What is that? Sir, it is converting high level language into low level language or target program. Along that, it can produce errors. It can produce errors if any in our program. If any in our program. So compiler is the translator or software which translates high level language into low level language. Along with that, it can produce errors if any in our program. So that is nothing but compiler, sir. So for this compiler, we are having six phases and two more things. One is lexical analysis, and coming to syntax analysis, semantic analysis, and intermediate code generation, code optimization, and code generation. So these are the six phases. To convert the high level language into low level language or target program or target language, it is passing through 6 pages. Along with these 6 pages, we are having one is symbol table. We are having symbol table, and one more is error handler. So these are the two things. Every phase is connected to symbol table, as well as every phase is connected to error handler. So what is the purpose of symbol table? What is the purpose of error handler? I will explain you one by one, sir. So initially, the user is providing high level language as a source program. For example, int a comma b. This is the one instruction in the program. So that instruction is, or that source program is giving to lexical analyzer or lexical analysis. And one more name for lexical analysis is scanner. And one more name for lexical analysis is scanner. The purpose of lexical analysis is it takes the source program as input. Lexical analysis, it takes input as source program and produces tokens. Or lexical errors. Lexical analysis is the first phase of the compiler, or we can also call it as a program. It is the one of the program. This program takes the input as a source code or source program or high level language and converts that into tokens. Or it produces an error if that is not a token. If the source program is not a token, or is some words are not considered as a tokens, it returns they are lexical errors. So finally, it takes input as source program and it produces output as tokens or lexical errors. And for this purpose, it uses lexical analysis uses finite automata and regular expression. So for this purpose, lexical analysis uses or lexical analyzer uses finite automata and regular expression. We know the finite automata. Finite automata is nothing but a mathematical model which is used to recognize the regular languages. And regular expression is nothing but it is the mathematical representation of rules. Rules is nothing but grammar. So already you have finished, I think you have finished the theory of competitions or flat subject in academics or in GATE. So in that, these two topics will cover. So finite automata and regular expression. Again, I will explain you, but simply the responsibility of the lexical analysis or lexical analyzer is it reads the input or source program and produces the tokens or errors or lexical errors, not a errors, lexical errors. Sir, how can we say the error is the lexical error? I will explain you the role of the lexical analyzer. Once again, I will explain you. So there I will explain the what are the lexical errors. When we call the error is a lexical error. When we call the error is the syntax error. So like that I will explain you once again. So here you just understand the input of the lexical analysis is the source program and it produces the tokens. And for this purpose, it uses finite automata and regular expression. So this is about lexical analysis phase. So the output of lexical analysis is the input for syntax analysis. What is the output of lexical analysis? Tokens. So the tokens are the input to the syntax analysis. So here the syntax analysis or syntax analyzer takes the input as tokens. Take the input as tokens and produces the output as parse tree. Sir, what is a parse tree or what is a syntax tree? So both are same, sir. Syntax tree or parse tree. So this is nothing but the tree representation for the token. So what is the input we are passing to the syntax analyzer is tokens. So suppose if we represent that tokens in a tree representation, we can call that one as parse tree. So there are different kind of parse trees, sir. For constructing the parse tree, there are different methods are there. We'll clearly see those things in syntax analyzer. So already I told you, so it is having 50% of weightage in GATE. Almost half of the marks we are getting from the syntax analyzer only. So we'll clearly discuss what is a parse tree, what is a syntax tree, like that. Just you just understand what is the input for the lexical every phase and what is the output from every phase. That means syntax analysis, what is taking the input and what it is producing, and a syntax analyzer, what it is taking as input and what it is presenting as an output. Sir, as a lexical analysis, it also produces errors. So the errors produced by the syntax analyzer is called as syntax errors. The errors the syntax analyzer produce is called as syntax errors. So the output of the syntax analyzer is parse tree or syntax errors. Suppose if it is good, it produces a parse tree. Suppose if there is any error, it produces syntax error. Sir, here lexical analysis is using finite automata as well as regular expression for recognizing or for producing tokens. Sir, what like this So what is the syntax analyzer using? So here the syntax analyzer using PDA and CFG. So PDA means push down automata and context free grammars. These two are also you can cover in flat or TOC. So even though I will explain you each topic very clearly at the that concept. So don't worry. So next one is semantic analyzer. Semantic analyzer. Sir, what is the input to the semantic analyzer? So here, so it is taking input from the syntax analyzer. The output of syntax analyzer is parse tree. Parse tree. So the semantic analyzer taking the input as parse tree. Taking the input as parse tree, and it is producing the output as annotated parse tree. Parse tree. Sir, what is the difference between parse tree and annotated parse tree? Sir, parse tree means just it construct the tree for the given token without taking the consideration of meaning. But here in semantic analyzer, it checks the type. It checks the type. That's why we are calling as syntax analyzer is the type checker. Type checker. And the difference between syntax and semantic analyzers are here we see the structure. We see the structure, but here we see the meaning for that structure. Here we see the meaning for that structure. Suppose if it is not meaningful, it produces errors. It produces errors. Those errors are called as semantic errors. Those errors are called as semantic errors. Here it is taking the input as parse tree and it is producing as an output as annotated parse tree. And if that is not produced the annotated parse tree, it may produce semantic errors if any. So and it uses SDT, semantic directed translation. Semantic directed translation. So in lexical analysis, that is using finite automata and regular expression to produce tokens. And coming to the syntax analyzer, it is using push down automata and context free grammars. Sir, there is a question. So many number of times. So we got a question from this area. So what is the input to the lexical analysis and what is the input to the semantic analysis or syntax analyzer or analysis, and what are the outputs produced by the each pages? So we got the questions from this area also, sir. In GATE previously asked questions. I will explain you after completion of this topic. What are the questions asked previously from this area? Okay, good. So the input is parse tree, the output is annotated parse tree or semantic errors, and it uses syntax directed translation. Syntax directed translation to produce the annotated parse tree. So next one is intermediate code generation. So intermediate code generation is the next phase of the semantic analysis. So it takes the input as annotated parse tree, and it produces intermediate code. So we can also call it as tree address code. Intermediate code generated. So tree address code. It produces tree address code. So we can also call it as intermediate code. Intermediate code. So the intermediate code generator produces intermediate code, that is 3 address code. And for this purpose, it takes the input. It takes the input as annotated parse tree. Annotated parse tree. And what it uses? What it uses? It uses syntax directed translation. Sir, in the semantic analyzer also we used SDT. So here also we use SDT only, sir, for constructing the 3 address code. So you can ask one question, sir, what is the purpose of intermediate code generation? What is the purpose to generate the intermediate code? Sir, we can write the programs. So in that program, unless code may exist in the our high level language or high level source program. So some unnecessary code or useless code may exist. Useless code may exist. So for that useless code or unused code or anything which is not useful is there in our program, so our program is not efficient. Our program is not efficient. To convert our program into efficient program, so we need to eliminate the code which is not useful, So for the purpose, we are doing code optimization. For the purpose, we are doing code optimization. In code optimization, we are removing the useless or unused or the data which is not required is eliminated. The data which is not required or the content which is not required or which is not useful for that program, we can eliminate using code optimization. For that purpose, to eliminate the data or code or instructions which are not useful, so we are converting our program or source program into intermediate code. Sir, again question, what is the need to convert the intermediate code? So you can directly remove useless code from high level language. Sir, that is very, very difficult. That is very, very difficult. To remove the unuseful code from high level language is very, very difficult. And also it is again very, very difficult to remove the unuseful data from the machine code. We cannot, or it is I don't say we cannot, but it is very difficult to remove the useless content from high level language, as well as from machine language also we can't remove, or it is very, very difficult. Sorry, we can't we can do anything. It is not I don't say it is not possible, but it is possible, but it is difficult. To remove the unuseful content or unused content or the content which is not useful in the high level language. So for that purpose, it is difficult with the high level language as well as it is difficult with the machine level language or low level language. For that purpose, between these two, we are converting the another code representation that is called as intermediate code. So hope you can you understand the thing. So what is the need of intermediate code? So without intermediate code also, we can convert the high level language into low level language for optimization purpose. Optimization means reducing the useless things or unuseful things. So that is nothing but optimization. So to do optimization, it is difficult with high level language as well as machine level language. For that purpose, we are converting the high level language into intermediate code, sir. So that is the purpose of the converting intermediate code, high level language to intermediate code. Good. So next page is code optimization. Next point is code optimization. So already we discussed this. So the input to this one is 3-address code. 3-address code, or we can also call as intermediate code. So the output of this one is optimized IC or optimized 3-address code. 3-address code. Sir, what is the difference between intermediate code and optimized intermediate code? Or what is the difference between 3-address code and optimized 3-address code? Suppose in 3-address code, if you are having 100 lines of code, so in that the 20 lines are not useful. So in the optimized 3-address code or optimized intermediate code, we can have 80 lines of the useful data only. In the code optimization, we remove the data or code or instructions which are not useful. So finally we'll get the optimized intermediate code after completion of the phase code optimization. So the last one is code generator or code generation phase. For this phase, we pass the input as optimized intermediate code, and it produces the target program or target code or low level language. So if anything, so what it requires, it can transform. So that is the purpose of the code generator. If you observe the thing in the intermediate code generator, I didn't write the errors because it is not producing any kind of errors. In the code optimization also, I didn't write the errors, and in code generator also, I didn't write any kind of errors. So with this, I can say that the errors are identified in 3 phases. They are lexical analysis plus syntax analysis and semantic analysis. In these 3 phases only, we can get the errors. That means we get most of the errors as a lexical error or syntax error or semantic error. You can ask a question, sir, if code optimization and code generation and intermediate code generator are not producing any kind of errors, why we are connected these 3 phases to error handler? Why we are connected these phases to error handler? So these are not produce any kind of potential errors, but these can produce fatal errors. These can produce some fatal errors. I think you know how many different kind of errors are there. So there are 2 types of errors, sir. So one is compile time errors. Another one is runtime errors. So here our task is compiler design. So we don't consider about runtime errors. Coming to the compile time errors, there are 3 types of errors. One is lexical error, and second one is syntax errors, and third one is semantic errors. So these are the 3 errors only. On this topic also, we are having one gate question. So what are the error phases and what is the not an error phase, or which phase does not produce any kind of errors? Like that, we got a question previously in gate. So this is about the phases of the compiler, sir. So we are having 6 phases. So lexical analysis, syntax analysis, semantic analysis, intermediate code generator, and code optimizer and code generator. Coming to the these 6 phases, we are having 2 more things. one is error handler, another one is a symbol table. Sir, what is the purpose of the symbol table? What is the purpose of the error handler? So already we discussed about error handler, I think, because to handle the errors at every phase, we are using error handler. So from lexic analysis, syntax analysis, and semantic analysis, we are getting potential errors. The errors are lexical errors, or syntax errors, or semantic errors. And coming to these three, we get an errors. Those errors are called as fatal errors. Those are not a potential errors. So we cannot differentiate those errors. So, but we can we may get errors. So that can be handled by the compiler. So, but those are not a potential errors. So okay, good. Coming to the symbol table. So what is the purpose of the symbol table? The data structure used in compiler design to store the information about identifiers and constants. Identifiers and constants are called as symbol table, or is called as symbol table. The data structure used in compiler design to store the information about identifiers and constants is called symbol table. So symbol table is the data structure. What is the purpose of this data structure? At every phase, it can have some information about identifiers and constants. That information can be stored. That information can be stored in symbol table. So like this. So here we have an instruction. Int A, B. So these are the some tokens. Here, comma is also a token and semicolon is also a token, sir. So I will explain you about these things. So coming to the major case, here we are having int. Int is the keyword. A is nothing but a variable, and B is also a variable. So what we are telling about symbol table? Symbol table is the data structure which can store the identifiers and constants, or the information about identifiers and constants. So it is the keyword. It is the identifier. It is the identifier. The memory required for this one is 4 bytes. 4 bytes. So in some compilers it may be 2 bytes because integer, and some compilers it is 4 bytes. Coming to the 32-bit process, it is 2 bytes, and coming to the 64-bit process, it is 4 bytes. So this is about the phases of the compiler. It is the discussion about phases of the compiler, sir. Sir, is it clear? If anyone are having any doubts regarding phases of the compiler, you can ask. Okay. Hope you don't have any kind of doubts. Okay, good. We'll see some questions. What we discussed, the topic. We'll see some questions, sir. And one more point, ma. So the one more point is here we are having 6 pages now. So one is lexical analysis, and second one is syntax analysis, semantic analysis, and intermediate code generation. These 4 are called as front end. And next, code optimization and code generation. These 2 are called as back end. Sir, why we are calling this one as a front end and why we are calling this one as a back end? There is a specific reason is there, sir. What is that specific reason is? So first the input is source program. So here all the phases of the front end are depending on the source program, and independent of machine. It does not depending on machine, but it is depending upon the source program. That's why we are calling this one as front end. And coming to the code optimization and code generation, it does not depend on source program. That means it is independent of source program, and it is dependent on machine. Based on the machine, suppose already I used that terminology, 32-bit and 64-bit, like that. So based on the machine, it has to produce the target code. But here, for converting lexical analysis tokens to parse tree, or parse tree to annotated parse tree, or annotated parse tree to intermediate code generation, not required to depending upon machine. So what is the source program we are using? We can convert or we can perform these pages, and in the code optimization and code generation, we need to optimize the code based on the machine. We need to generate the code based on the machine. That's why these two phases are depending on machine. We are calling that in the situation we are calling these two as back end, and these four as front end. So this is the one more major point you need to remember. So good, sir. So I will write the questions. So match the following according to input to the compiler phase, So list 1 and list 2. Coming to the list 1, syntax tree, A, some B, character string, and some C, intermediate representation, and coming to D, token string, and coming to list 2, 1, code generator, and 2 is syntax analyzer, and third one is semantic analyzer, and fourth one is lexical analyzer. So this is the question which is asked in previous gate, sir. So what is the question is, match the following according to input. So according to the input we need to match. So what is the input to the syntax tree, sir? What is the input to the syntax tree? The input to the syntax tree is tokens. Input to the syntax tree is tokens. I'm sorry. I'm sorry, sir. Yeah. So what is the input to the syntax analyzer, sir? Syntax analyzer take the input as token. So already we discussed about these things, sir. So what are the inputs? So syntax analyzer, the input is tokens, and semantic analyzer, the input is parse tree. We can also call it as syntax tree. We can also call it as syntax tree. Coming to the semantic analyzer, the input is annotated parse tree. Sorry, coming to the semantic analysis, the input is parse tree. Coming to the syntax analysis, the input is tokens. Coming to the lexical analysis, source program. Source program is nothing but character string. Character string, because that is the raw data. Because that is the raw data set. So these are the things. From these things, here we are having question. What is the question? The input to the syntax analyzer. The input to the syntax analyzer is tokens. The input to the semantic analyzer. Semantic analyzer is parse tree or syntax tree. Parse tree or syntax tree. What is the input to the lexical analysis? That is the raw data. We can call it as character stream or source program also. So what is the input to the code generator? So that is nothing but optimized code, like that we told. But here the option is given as intermediate code representation or intermediate representation. So here the matching is syntax analyzer takes the input as token streams, and lexical analysis take the input as character streams, and semantic analysis or semantic analyzer takes the input as parse tree or syntax tree. And last one is intermediate representation is the input to code generator. Hope you understand. So here already the topic we have discussed, what is the input to every phase and what is the output from every phase. So here the question is, what is the input to the phases? So what is the input to the syntax analyzer? What is the input to the semantic analyzer? What is the input to the lexical analyzer? What is the input to the code generator? So the code generator input is intermediate code representation or optimized intermediate code representation. And coming to the syntax analyzer, that is tokens. Syntax analyzer. Sir, don't confuse input. We are telling input. Suppose output means code generator produces target code. Syntax analyzer produces parse tree. And semantic analyzer produces annotated parse tree. Annotated parse tree. And lexical analyzer produces tokens. The tokens are output to the lexical analysis and input to the syntax analysis. And the parse tree is the output of the syntax analyzer and input to the semantic analyzer. And intermediate code representation is the input to the code generator and output of the intermediate code generator. So like that you have to understand. So we discussed clearly about those inputs and outputs. So what are the inputs we are passing to every phase and what are the outputs they are giving? So the lexical analysis giving output as token, or else it can produce lexical errors, or syntax analyzer producing output as parse tree or syntax errors. It is taking the input as tokens. And coming to the semantic analyzer, it is taking input as parse tree and it is producing output as annotated parse tree. With this, it is using syntax directed translation. In the lexical analysis, that is using finite automata and regular expression. And coming to the syntax analysis, that is using pushdown automata and context free grammars. Coming to the intermediate code generator, it is taking input as annotated parse tree and producing the intermediate code or tree address code. So it is using for that syntax directed translation. Coming to the code optimization. So in the code optimization, it is taking input as 3 address code or intermediate code generation, and producing the output as optimized intermediate code or optimized 3 address code. So that means it is eliminating the code or instructions which are not useful for the program. So by doing this, we can increase the efficiency of the program. So without the intermediate code also, we can do the same thing, but it is difficult because from high level language or low level language, it is difficult to identify the errors or identify the content which is not useful and to optimize. For that purpose, we converted the source program into intermediate code. So, and finally, so it takes the code generator takes the optimized intermediate code and produces the target program or target code or low level language. So simply we can call it as assembly language in form of C language. So this is about lexical analysis pages, sir. And along with this, we discussed about symbol table and we discussed about error handler. And one more question, sir. So one more question. So in a compiler module, sir, here he called it as module. So we know about function, we know about module, we know about program. So everything is collection of instructions to do a specific task. So in a compiler module, that means compiler is the program, or compiler is a collection of programs, or we can call compiler is a software also. So that checks every character of source program or source text is called in a compiler module that checks every character of the source program or source text is called. Who will check the source program? Who will check the source program? Option A, code generator. Option B, code optimizer. And option C, lexical analyzer. And option D, syntax analyzer. Here the question is, in a compiler module or in a compiler, we are having different kind of phases. So the phases are lexical analysis. Simply you can remember as LSS. So lexical analysis, syntax analysis, and semantic analysis. And coming to the next one, so ICC. So intermediate code generator, code optimizer, and code generator. Intermediate code generator, code optimizer, and code generator. LSS and ICC. So these are the phases. In these 6 phases, which phase responsibility? Checking the source program. Which phase responsibility? Checking the source program. So initially, which phase taking the source program? So source program is passing to lexical analysis. That has to check. So, and syntax analyzer, what is the input to the syntax analyzer? That is tokens. And what is the input to the semantic analysis? That is the parse tree. For intermediate code generator, that is the annotated parse tree. And one more thing is, here I explained code optimization and code generation, not depending on the source program. That means there is no connectivity. With source program for code optimizer and code generator. So we can eliminate 2 options. So the eliminated options are, So this one and this one, these two are not correct because those two are not using source program as well as not depending upon the source program. That is the point we covered previously. So coming to the next two things. So which is taking the input as source program? Is it syntax analyzer or lexical analyzer? So syntax analyzer taking the input as tokens, but lexical analyzer taking the input as source program. So who will check the source program? That is the responsibility of the lexical analyzer, because that is considering the input as the source program. So the answer is lexical analysis and not a syntax analyzer. Syntax analyzer in a compiler module that checks every character. And one more thing is also this. So already I told you, lexical analysis is we can also call it as scanner. The responsibility of the scanner is read character by character from left to right. So that is the responsibility of the scanner. So what is the responsibility of the syntax analyzer? Just constructing a structure. So finally, we can give the answer as lexical analyzer, which checks every character by reading character by character. So the answer is lexical analyzer. Code optimization or code optimizer and code generator are not related to source program. We covered that. So these two are not depending upon the source program. That's why those two are not considered. So we can directly eliminate these two. Coming to these two, so lexical analysis taking as input as a source program. From that, we can consider lexical analyzer answer. Or also, we are having one more point, that is scanner. So scanner responsibility is it reads the data character by character from left to right. So in this way also, so it is the responsibility of the lexical analyzer to check every character. So this is about the answer is lexical analyzer, sir. Right. Next question. So these all questions are depending on the phases only, sir. So what we discussed, from that only I am writing the questions. We are having many number of questions from lexical analyzer, but I am writing only the topic we covered, only the topic we can cover. So right. So which data structure? Yeah, hope you can give the answer for this. Which data structure in compiler is used for managing information about variables and their attributes means constants. So not given in the questions are constants means. So which data structure in a compiler is used for managing information about variables and their attributes? Option A, abstract syntax tree. And option B, symbol table. Option C, semantic stack. stack. Sir, all these questions are asked in previous gate. So I'm not writing my own. So these questions are previously asked questions in gate from the phases of the compiler. From the topic of phases of the compiler, we got these all questions in previous years. So parse table. So these are the options given, sir. So the question is, what is the data structure? What is the data structure in a compiler? Sir, what is the data structure in a compiler? What data structure we are having? What data structure we are having? What data structure, sir? Is the symbol table is the data structure? So it stores the information about the identifiers and constants. So this is the thing we discussed. Symbol table is the data structure. Yes, sorry. Yeah. So here only I have written. So symbol table is the data structure which is used to store the information about identifiers and constants. So here it is the direct question. So what is the data structure? Sir, in compiler we are having only one data structure. The data structure is the symbol table. The data structure which we used in compiler design is the symbol table. Anyone ask the question, sir, in data structure we are having two kind of data structures. One is a linear data structure, another one is the non-linear data structure. Non-linear data structure. Coming to here, it is trees and graphs, and coming to here, arrays, linked list, stack, and queue. Sir, where is the symbol table as a data structure? Where is the symbol table as a data structure? So what is the difference between these all data structures and this data structure? So symbol table is just a name, sir. This is not a data structure. This is just a name. Here we use one of these data structures only. Here we use hash table data structure. So the properties of hash table is, for searching any information, the time complexity is big O of 1, because this is the dictionary implementation. In dictionary, suppose if you want to search any information, we can directly move to that particular place. So for that purpose, to find out an element or any data in the hash table, the time required is big O of 1. So that is the best time complexity. For that purpose, in compilers, we are using the hash tables. We are using the hash tables to implement the symbol table. Here the symbol table is just a namesake. Just a namesake. But suppose if he given hash table as a one of the data structure in this. So what is the answer, sir? Hash table is also one of the option, like as abstract syntax tree, symbol table, and semantic stack, as well as hash table. The answer is a symbol table only, because in compiler we have given one name to data structure. The name is symbol table. The name is symbol table. That's why we have to give the answer as a symbol table. Suppose if we ask a question as, what is the data structure used to implement a symbol table? The answer is hash table. The answer is hash table. Okay. So next question is, here it is also a matching only, sir. So list one. So it is also from the phases of the compiler. I'm very happy if any one of you give the answer for this. P, lexical analysis. Lexical analysis. Q, top-down parsing. So I didn't mention this terminology, top-down parsing, till now, but here is a question, top-down parsing. I will explain you. Next one is R. R is semantic analysis. Semantic analysis. PQRS. S is runtime environment. Runtime environment. So runtime environment is nothing, not a phase, sir. It is the part of the code generation. It is the part of the code generation. So coming to the list 2, option 1 is leftmost derivation. Leftmost derivation. And second one is type checking. Type checking. And option 3 is regular expression. Regular expression. And option 4 is activation records. Activation records. So you can half of the part you can get the answer for this question, sir, I think. So what is the input for lexical analysis? What is the input for lexical analysis? That is source program. And what is the things used by the lexical analysis? Finite automata and regular expression. So with this point, is it possible to match regular expression and lexical analysis? Yes, because the lexical analysis uses regular expression to construct tokens or to return tokens. To return tokens, it uses regular expression as a tool. And second one, so direct point. This is the direct point. So the thing is, yes, sir. So semantic analyzer act as type checker. Semantic analyzer act as type checker, sir. So here we can also map or we can also match semantic analyzer. Semantic analyzer is used to type checking. So remaining things, top-down parsing and runtime environment, activation record, leftmost derivation tree are not belongs to these things, sir. So these are belongs to top-down parsing and leftmost derivation is belongs to syntax analyzer. In syntax analyzer, we are having two types of parsings. One is a top-down parsing, another one is the bottom-up parsing. Coming to the top-down parsing, we use LMD, leftmost derivation. Another one is bottom-up parsing. In bottom-up parsing, we use RMD in reverse. That means leftmost derivation. So these terminology, leftmost derivation and rightmost derivation terminology is you may use it in theory of computations in grammars. So suppose, even though if you don't have knowledge, I will explain you in the parsing topic clearly what is parsing, what is top-down parsing, what is LMD, what is RMD. When we call LMD, when we call RMD, what is the leftmost derivation tree, rightmost derivation tree, everything I will explain you, sir. So here the thing is these two are matched. So finally, we don't have knowledge on this one because I didn't explain you about runtime environment as well as activation record. I didn't use terms. What is activation record? What is a runtime environment? Just remember it, sir. So I will explain it in the runtime environment as well as code generation. So this is the matching. Sir, why here you used this question? So most of the part we covered. Here, syntax analyzer, type checking we covered, and lexical analysis and regular expression also we covered. So for that purpose, I explained this question in this topic, sir. So here I need to explain you about top-down parsing as well as leftmost derivation tree and runtime environment and activation record. So in the next classes, I will explain about these things clearly. So remaining things, lexical analysis, you know about it, and type checking, you know about it, regular expression, you know about it, and semantic analysis, you know about it. So this is the thing, sir. Hope you understand. If anyone are having a doubt on this, please ask, sir. Till now, if you are having any doubts, please ask me. I will explain you clearly. Here in comparative design, the thing is you have to know about the terminology. Mainly, you have to know about the terminology. With having good knowledge or a good gain of the terminology, it is very easy to answer the questions. So we all questions till now we answered 4 questions. All the questions we answered from the topic only, sir. From the topic only, everything we discussed. So from that topic only we answered. So some more questions are also there, sir. Right. So next question is, it is also a direct question. Type checking. Type checking is normally done during option A, lexical analysis, and option B, syntax analysis, option C, syntax directed translation, option D, code optimization. Can anyone answer for this question?
Syntax directed translation, sir.
Why, sir? Why it is not a lexical analysis? Why it is not a syntax analysis? How can we eliminate this? Yes, sir. Answer is syntax directed translation.
Because lexical analysis uses FA and RE, whereas syntax analysis uses PD and CFG.
Okay.
In semantic analysis, we use STT, sir.
Yes, sir. Yes, sir. Like that only, like that we can answer. Or else, here we directly given semantic analyzer and syntax directed translation and type checker. These three are belongs to one category. So these three are belongs to one category. Actually, this is some critical question, because so if we ask the questions like this, lexical analysis and syntax analysis, here he has to give option as semantic analysis. Suppose if it is a semantic analysis, we can directly give the answer as semantic analysis, no issue, because in the lexical analysis we recognize tokens, and in syntax analysis we produces tokens. Here we produce parse tree, and here we produce annotated parse tree, and that means, and one more thing I explained. Yeah, syntax analyzer focus on structure, and semantic analyzer focus on meaning. So type checking means, so what it is type of, it is an integer or a float or character, like that, sir. So these are the things, sir. So these are the previously asked questions, sir. And there is one more question. I will write it. Okay, thank you. In a compiler, keywords of language are recognized Keywords of the language are recognized during. Option A, parsing of the program. Parsing of the program. Option B, code generation. And option C, lexical analysis of the program. That means lexical analysis of the program. And option D, data flow analysis. Data flow analysis. Right, sir. So here also, you know about parsing, and you heard about parsing, and you heard about lexical code generator and the lexical analyzer, but you didn't heard about data flow analysis. You didn't heard about data flow analysis. Sir, what is the data flow analysis? So 1 minute, sir. Yeah. Here we are passing input as regular expression and finite automata. And here we are passing in lexical and in semantic analysis, push down automata and context free grammar. And coming to the semantic analysis, it is SDT. And coming to the intercode optimization, here we use data flow analysis as an input. So that means the data flow analysis belongs to code optimization or code optimization phase, because to optimize the code, we need to know how the code is executing. So with that knowledge only, we can reduce or we can eliminate the unnecessary instructions. We can reduce or we can eliminate the unnecessary instructions with the help of data flow analysis only. So here the data flow analysis is the tool used by the code optimization, like as regular expression and finite automata used by the lexical analyzer, and push down automata and context free grammar is used by the syntax analyzer, and the syntax directed translation is used by the semantic analyzer as well as intermediate code generator. The code optimization use some data flow analysis. So you can ask, sir, what about code generator? Sorry, code generator use some standard algorithms as tools to convert this optimized intermediate code as target program. So with this you are having knowledge. What is that knowledge? So every phase taking something as an input and every phase producing something as an output, and to produce that output, every phase using some tools. So coming to the lexical analysis, it is using finite automata as well as regular expression. Coming to the syntax analyzer, it is using push down automata and context free grammar. And coming to the semantic analyzer, it is using syntax directed translation. And coming to the intermediate code generation, it is also using syntax directed translation. Coming to the code optimization, it is using data flow analysis as a tool to produce the optimized intermediate code. And coming to the code generator, it is using the standard algorithms to produce the target code or target program or low level language. So right. So please come to our program. Sorry, our question. So here in a compiler, you know about the compiler. Compiler, we are having 6 pages. So in a compiler, keywords. In a compiler, keywords. Sir, what is a keyword? What is a keyword? Okay, I will explain. Keywords of languages are recognized during A time low. Sorry, in which time we are recognizing the keywords? At the time of parsing, or at the time of code generation, or at the time of lexical analyzer, or at the time of data flow analysis. So please come to the starting step once. Yeah. So what is the responsibility of the lexical analyzer? The lexical analyzer take the input as a source program and it produces the token. So now my question is, what is token? What is token? Token may be, so 5 different things. One is token may be, one is constant, one is constant. Second one is identifier, and third thing is special character or special symbol, or token may be operator, and finally token may be keyword. Sir, how many number of keywords are there in C? There are 32 keywords. There are 32 keywords. Interfloat, for, case, break, continue, if, else, do, while, like this, long, short, like this. We are having 32 keywords. So here the meaning of the keyword means these 32 keywords. These 32 keywords. So these 32 keywords are recognized as tokens. These 32 keywords are recognized as tokens. So the token is identified during the lexical analysis of the program. We are recognizing the tokens. The keyword is the part of the token. So here the answer is lexical analysis of the program. Right? You may ask the question, sir, why not at parsing? Why not at code generation? Why not? It is the data flow analysis. Because in parsing of the program, we are recognizing parse trees, or we are producing parse trees, but not tokens. Suppose if any token is recognized, that token may be constant or identifier or special character or operator or keyword. So that is recognizing at lexical analyzer, but not at parsing. Parsing, we are recognizing a tree, parse tree or syntax tree. That's why it is not the correct answer. In the code generator, there is no dependency on the source program. That's why this is also not the correct option. Coming to the data flow analysis, it is not the phase, it is the tool. It is not the phase, it is the tool which is used in code optimization. It is the tool, it is not the phase, it is not the compilation process. It is the tool used at optimization or code optimization. That's why that is also not the correct option, sir. So these are the things we have discussed. These are the previously asked questions from the different phases of the compiler. Most of the questions, if you observed, what is the input, what is the output, and what is the tool we are using what is the responsibility of the phase? Every phase is having separate responsibility. So lexical analysis is producing tokens. Syntax analysis is producing parse tree. Semantic analysis is producing annotated parse tree. An intermediate code generator is producing 3 address code. And code optimization producing optimized code by reducing the things which are not useful. After that, code generator is producing assembly language or code target code or any target program. So every phase having unique task, or every phase performing unique task. That's why we need to remember, or we need to having the knowledge on what is the input to that phase, what is the output from that phase, what is the responsibility of that phase, and what is the tools used at that phase. These 4 things you have to put in, you are having the knowledge to answer the questions like, so lexical analysis. To answer the lexical phases of the compilation questions, you need to knowledge on 4 things. What is the input to the every phase? What is the output from the every phase? What are the tools used at that phase? And what is the responsibility of the phase? Along with this, so we discussed 2 more things: symbol table and error handler. So there are 3 types of errors only. Lexical errors and syntax errors and semantic errors. So remaining all errors are called as fatal errors. So these 3 phases only produce the errors, which is not the error producing phase. Like that, you may get the question. I already asked in the previous questions, one of the question, which is not produce the, which is not covered in the error phase. And one more thing I discussed. So there are 2 ends. One is the front end, another one is the back end. So coming to the front end, which is depending upon the source program, and which is coming to the back end, which is not depending upon the source program, but it is depending upon the machine. Coming to the front end, it is depending upon source program, but not on the machine. So this is about the phases of the compiler, sir. So from next onwards, we discuss each phase very clearly. Lexical, what is the role of the lexical analysis? What are the errors it produces? What are the different kind of tokens are there? So already here we mentioned there are 5 different kind of tokens. So how we recognize constants, how we recognize identifiers, how we recognize special characters, how we recognize operator, how we recognize keywords. So these are the things. So everything other than these 5, so those are not a token. Other than these 5, everything is not comes under token. So suppose if it has to comes under token, it has to be a constant, or it has to be a identifier, or it has to be a special character, or it has to be a operator, or it has to be a keyword. So these 5 only comes under token, which are recognized by the which are produced by the lexical analyzer. Other than these, everything is lexical error, because that is not a token. If it is not a token, it is an error. Where we find that error? Lexical analyzer. That's why we are calling those are lexical errors. So that is the thing, sir. So next concept is role of lexical analyzer. So lexical analyzer is the phase, or we can also call it as a program. It takes input as source program, and it produces tokens as output. For that, it uses finite automata plus regular expression. For that, it uses finite automata and regular expression. If the output is not a token, it may be lexical error. That means lexical analyzer produces a tokens as output. If it is not a token, it produces lexical error as an output. So this is the responsibility. So with some elaboration, if you talk about lexical analyzer, so another name for lexical analyzer is scanner. Another name for lexical analyzer is scanner. So what are the roles? So it reads source program. Character by character, and produces tokens. This is the first point or major point, which is done by the lexical analysis. Reads the source program character by character and produces the tokens, or generates the tokens. Anything produced or generate the tokens. And second point is it ignores comments. Because comment is not a token. So manaku telusu, in C language comments are written like this. So or else we can write double slash. So these are called as comments or documentation section or comment section like that. So these are ignored by, or these are skipped by lexical analyzer. Skips or ignores comments. And second thing, it ignores blank spaces or new line or tab, \t, \n, like that, or blank spaces. These all are ignored by lexical analyzer. That means eliminates also. Ignores or eliminates. So from the given source program, it eliminates all these things. What are the things it eliminates? Comments it eliminates, and blank spaces, new line, and tab space, all these things ignored by or eliminated by the lexical analysis. Only tokens are produces as an output. Remaining things are ignored. Along with this, it produces errors. If any. In our program. Next one is, here it is also construct symbol table. It also construct symbol table for identifiers and constants. And finally, it gives the tokens to the parser. Gives tokens to the parser. So these are the roles or responsibilities of the lexical analyzer. Lexical analyzer is also called as scanner. It reads the source program character by character and produces tokens. That is the major responsibility of the lexical analyzer. Along with this, it produces at the time of producing tokens, it also removes or ignores comments or blank spaces or new line. So these all are ignored or removed by lexical analyzer, and it also produces any errors exists in the program or source program. And coming to the last, it constructs a symbol table for identifiers and constants. Identifiers and constants. It symbol table is the data structure which manages information about identifiers and constants. And coming to the last one, it gives the tokens to the parser. It gives the tokens to the parser. So this is the role of the lexical analyzer. Lexical analyzer. Here we are having one question. Why lexical analyzer and parser are separated? Are the difference? What are the differences between lexical analyzer and parser? Are also ask the question like why we are not combining lexical analyzer and parser? Why we are not combining? Why? What is the reason to write to take the two separate phases? So one thing is lexical analysis and parser or syntax analyzer. Why they are divided? Why they are separated? This is the question. First point is for simplicity of design, because lexical analyzer is recognizing the tokens and parser is constructing the syntax tree. So it is doing one specific task and it is doing another specific task. Suppose if we combine these two, so that phase, the combined phase, has to recognize the tokens as well as construct the parse tree. So this is the hectic task. So that's why for simple design, for simple design, it is designed for recognizing tokens and it is designed for constructing syntax tree. For simple design, these two are separated. And second question, so with this terminology also we are having previous gate questions. Why these two are separated? What is the reason? What is the reason for the separation of parser and lexical analyzer? For the parser and lexical analyzer, why these two are separated? Why don't we are combining these two? Because there are some reasons are there. One reason is for simple design, for simplification, or for simple design. And second thing is for efficient compiler, improving the efficiency of the compiler, improving the efficiency of the compiler, for improving the efficiency of the compiler. So we divide the lexical analyzer and parser as two. So, and last one is enhancing the compiler probability, enhancing the compiler probability. So for these three reasons, these two are separated. For those three reasons, they are separated. There is a one question, sir, on that. Please wait. Sir, in the next class, I will give the question on this one. So this is about the role of the lexical analysis or lexical analyzer and phases of the compiler. So in this class, we discussed about phases of the compiler, one point, phases of compiler, and second thing is role of lexical analysis. So it is not completed, just the things I explained you. So what are the roles? So the role of lexical analysis reads the character by character from left to right from the source program and produce the tokens. And second thing is ignores the new line, ignores the comments, ignore the tab spaces, ignores the white spaces, or removes those all things. And coming to the next one, it produces errors if any. And next one is it returns tokens or it gives tokens to the parser. So these are the things. How it is recognizing tokens. How it is recognizing tokens. There are two ways are there, sir. One is by using lex tool we can recognize, or by writing handwritten program we can recognize. Sir, this topic is not in the gate. This topic is not in the gate, sir. So no need to discuss about lexical tool. What is the need of lexical tool? How it is recognizing tokens and all these things. So we do, or we can recognize the tokens by handwritten programming. So in this handwritten programming also, for recognizing tokens, we use or we implement finite automata with the help of regular expression. So what is the regular expression? What is the finite automata? How we construct a finite automata for the given token? How can we say the token is recognized? How we can say that token is not recognized? So these are all things we discuss in the next class, sir. So here I mentioned you, the thing is you need to have the knowledge on terminology. You need to have the knowledge on terminology. Terminology is very, very, very important, sir. Without clear understanding of the terminology, it is difficult for you. Otherwise, it is very, very easy. So every question we solved in the from the given topic only. Every question, all the questions we solved from the topic we discussed. So by knowing the terminology, by understanding the definition or the purpose of the terminology, the things, we can easily answer the questions in the compiler design. So please focus on the terminology. If you are unable to understand, please ask, sir. So I will definitely explain you. So in a clear manner. So once again, so please focus on that thing. So if you are anyone are having any doubts from the class, please ask, sir. I will explain. From phases of the compiler, or role of the lexical analysis, or a token, what is a token, like, or what are the inputs for every phase, what are the outputs for every phase, what are the tools used at every phase, and what are the errors produced at phase, and where the symbol, what is the purpose of the symbol table, what is the purpose of the error handler, everything. Suppose if you are unable to understand anything, if you are having doubt on any topic, you please ask, sir. I will explain. So if everything is understand, don't have questions. If nothing understand also, no questions. So what is the situation? I don't know. Is there anyone? Please respond. Can anyone please respond? Is there any questions, ma'am?
No doubt, sir.
No doubts. Is everything is good?
Yes, sir.
Yeah. Is my class is any speed or like or is it is okay?
Okay, sir.
Okay. Thank you. Thank you. Okay. Okay, ma. I will stop make a class here. Tomorrow evening also we are having class from 6 to 8. In that class, I will clearly explain the role of lexical analyzer. So how we are identifying the tokens or how we are recognizing the tokens. Suppose if it is not a token, how can we say that is a lexical error? So clearly I will explain you that is the very good topic and a very interesting topic also. So the recognizing of tokens by using finite automata and regular expressions. So so many questions are there previously asked. How many number of tokens are there? What is the lexical error available in this given areas? Like that we will get the questions in that. So I will explain you in the tomorrow class. Thank you.